Hello, everyone. Hopefully you can hear the volume and hear everything okay. I'm now going to share my screen. So today we're going to be going over a one sample mean test, a two sample independent samples test, a chi-square test, and a one-way ANOVA test. So for a one sample t-test, one sample mean test, the steps are as follows. You go to Analyze, Compare Means, then we'll do one sample mean test. And in this case, we're going to select a Duke. Let me fix that. A Duke. Here we go. We're going to do 13 as the value. And then we're going to select our confidence interval. Then we're going to click a continue and OK. And then we're going to reject or fail reject the null hypothesis based on the p-value for that confidence interval. In other words, we're saying what is the likelihood of our sample mean being a particular value, such as 13 years of education. So I'm going to share my screen for SPSS. And I will show you how this is done. So we're going to go to Analyze. I'm going to go to, one moment. Compare means. We're going to do one sample t-test. And to find the variable, we're going to do a Duke. And we're going to click on Options. We're going to keep it 95% confidence interval, click Continue. And for our test value, we're going to see if it's 13. So we can form two hypotheses based on this. We can suggest that the population mean is not different from 13, or the population mean is different from 13. Another way of saying this is our null hypothesis is saying that our population mean for years of education is 13, and the alternative hypothesis is that the years of education does not equal 13. So I'm going to click OK. Let me make sure you can see this output. All right, here's our output for our one sample mean test. We see that our sample mean is 13.73. Now we want to know if this is statistically significantly different from 13 years of education. And we see we get a t-value of 11.914. And we get, for a one-sided t-test, it's p is less than 0.001. And for two sides, p is less than 0.001. Therefore, we can reject the null hypothesis, which suggests that 13 years of education is considerably different from the population mean, and that it's statistically significantly different. Therefore, we reject the null, which suggests that our value would be different from the population mean. And if you notice, we also see the standard deviation, we see the mean, etc. So that is a very simple one sample mean test. Go back to our review sheet. So again, go through the steps and you reject or fail to reject the null hypothesis. Now we're going to run a two samples independent samples t-test. Again, similar steps. We're going to do Analyze, Compare Means, Independent Samples t-tests, and we're going to do this with sex and hours worked, which is HRS2, and we're going to select the confidence interval, then click Continue. We're going to have sex as our grouping variable, and we're going to have that be the group to see if there's a difference between males and females. We're going to click OK. And those are going to be the two groups we're comparing, which makes sense. And then we're going to see if there is a difference based on the p-value. So I'm now going to share my SPSS screen again. So we're going to do Analyze, Compare Means, Independent Samples t-test. And now for our grouping variable, we're going to do sex. And we're going to do hours 2 as our test variable. We're going to click on options. We're going to keep our 95% confidence interval, and we're going to click continue. We're going to define our groups, and we know that our groups are 1 and 2 because gender is defined as 1 and 2. Male is coded as 1, female is coded as 2. We know that I'll show this after just to show how I know. Click continue, and we're going to click OK. Now we have our group statistics, and these groups, we're seeing if there's a difference between males and females and hours worked in the week, usually worked in a week. So there's 17 males and there's 31 females. Sorry. Yes. And we have a mean of 40 and 37.26 for females. But is that a statistically significant difference between the two groups? So we have a F value of 1.604. We can assume equal variance is assumed, and we see that statistically significant value is 0.212. Therefore, we would fail to reject the null hypothesis, which suggests that the groups are the same, that the amount of hours worked in a week is the same for both groups. And that would be how we interpret our independent samples t-test. One way to distinguish independent samples t-test and others is we want to know specifically if there is a difference between the groups. If we just want to know if there is specifically a difference between the group, but not specifically which groups, that would require a different test, which is an ANOVA test. But first, we're going to do a chi-square test, which again, to do a chi-square test, we're going to do analyze, descriptive statistics, crosstabs, and we're going to see if there's an association between race and ever having an abortion. We're going to click statistics and select chi-square, click continue and OK. So I'm now going to share my SPSS screen again. So now I'm going to do analyze, descriptive statistics, and we're going to do a crosstab. But this time we're going to do race and ab-any as our variables. As with the crosstab before, we are not particular about which variable goes in row or column. We're going to click on statistics, and we want the chi-square statistic. Now, if you would like certain percentages, we can do row and column and click continue. And we're going to click OK. Now we could do the same thing we did before with our crosstabs to see the association between each of these variables. Now, generally speaking, you'll do a chi-square for two categorical variables. You can do it for continuous variables. But generally speaking, if you want to know an association between two categorical variables, you will use a chi-square test. And if we scroll down, in addition to seeing the different percentages, for example, if we want to see if there's an association, we can see from Pearson chi-square, we see that the two-sided curve is 0.202. 0.202 is greater than 0.05. So we would fail to reject the null hypothesis, saying that there's not an association, or in other words, there's not a difference in abortion by race, and we would fail to reject the null hypothesis. And finally, we're going to go over a one-way ANOVA test. It's very important to be able to distinguish between an independent samples t-test and a one-way ANOVA test. This is another way of distinguishing the two. If you want to know specifically what the difference are between two groups of a variable, let's say I want to know the difference between, let's say I'm looking at religion, and I want to know specifically the difference between Catholics and Protestants. If I want to know a difference between those two groups specifically, I would do a two samples independent samples test. However, if I just want to know broadly if there's a difference by groups among the different religious affiliation groups, I'm not looking for what the difference is, but a difference between groups, I would do a one-way ANOVA test. And similar as before, you will do analyze, compare means, one-way ANOVA test, and we're going to be doing church attendance by marital status. And we're going to then select post hoc and then select Tukey, click continue and OK. And we want to keep an eye on the p-values in the ANOVA box. One moment. I'm in the wrong screen, sorry. Here we go. So we're going to do analyze, compare means, one-way ANOVA. And we're going to look and see if there's a difference in marital status by attend. Sorry. There we go. So our dependent variable is going to be church attendance, which although it's an ordinal variable, we're going to treat it as a continuous variable. That will be our dependent variable. And our independent variable will be a categorical variable, which is marital status. There we go. We're going to look at post hoc, and we're going to do Tukey's B. I think it's Tukey. I'll do both, Tukey's and Tukey's B. I'm going to click continue. And look at options. Our confidence interval level is 0.95. We're going to keep that. And I'm going to click OK. All right. So we see the ANOVA. The difference between groups is 0.001. So therefore, it suggests there is a difference between at least one of the groups. And it does give us some breakdown below to suggest what that might be. But we will go overall by this box, this first box right here, which is the overall effect of differences between groups. And because the p-value is less than 0.001, because 0.001 is less than 0.05, we reject the null hypothesis, which suggests that there is no difference between the groups. And that's a really, really simple breakdown. Now we can suggest possibly what those groups are, such as married and widowed, and single and never married. But again, what we're looking for is just to see, generally speaking, if there's a difference. We're not being specific about which groups differ. So that is one-way ANOVA. See if there's anything else before we continue. Those are the overall explanations. As with the other videos, feel free to look at the links to explain how we do everything. But hopefully these videos are helpful. And as always, if you have any questions about these videos, feel free to let me know. We will also cover content in class as well. Thank you very much for your time. Thank you for your participation, and I hope you have a great day.